oopy dots demo. So for oopy dots demo, we're going to start with this code here, which we will copy. And now we will head over here and paste it. And then we'll go ahead and run it. When we run it, we get over here. This is just like our dots, but let's actually run this again and see if I can drag this over here. When I click, I get a dot. The next time I click, I'm going to get a dot that moves. The next time I click, I'm going to get a dot that moves and flashes, a flashing moving dot. Then I'll get back to a stationary dot, a moving dot, and a flashing moving dot, and so on. If I click inside the dots, just like in our better dot demo from our oop1, we get a counter that goes up. Finally, we have a print a count of the dots that have been created so far. Every time we create a new dot, that count goes up. So we want to create this as a showcase of object-oriented programming. Great. And to do so, we're going to start from in our schedule. We'll go to oop part 1, and we'll go to better dots demo, and we'll start with that. We'll copy that, go over here, paste and run, and we'll see in better dots demo, I create dots, and when I click in the dots, they go up. This is from earlier in the semester. This is our starting point. I'd already used oop to create the dots. We're now going to use inheritance to create moving dots and to create flashing moving dots. So here we go. So first, to create a moving dot, we go ahead and we create a subclass of dot. Here's our class dot. We'll create a subclass of dot, class moving dot. It's a subclass of dot. Initially, we'll just pass. And when we create a dot, now what we'll do is we'll say if I have an even number of dots, mod2 is 0. Let's do len of data dots mod2 equals 0. If that's the case, then we'll go ahead and do that. Otherwise, we'll go ahead and we'll create a moving dot. So now, half my dots are dots, the other half are moving dots. Could it possibly work? Is that a valid class? You bet it is. And we come down here, there's a dot, moving dot, dot, moving dot, dot, move. Now the moving dots aren't moving, they're exactly the same as dots, but that's what this says right here. This says a moving dot is the same as the dot, except for nothing. It inherits everything from dot. Moving dots are dots. Let's fix that. So now we want to add the fact that moving dots move. Okay, so for that, we have to think about when would things move. Things move in response not to key presses or mouse presses, but in response to a timer fired. So down in our timer fired, instead of doing nothing, we want to say for every dot, go ahead and tell that dot to take a step. And we'll pass in the data because we know it's going to need it because we just do. So now that's for every dot. The thing is, dots right now don't know how to step. You have to go to the dot level and say, hey, if I'm a dot, the way that I take a step of self comma data is to do nothing. So dots, when they step, they do nothing. But you still have to define this method to give us a method to override here. Now, the other way we could have done it is down here. We could have said, if the dot is an instance of moving dot, then call step. But that's a little messier, I think, testing for the type down there. Instead of just letting inheritance take care of that test for us, by just calling step on all of them, the top level step does nothing, but moving dot overrides that step. And what does it do? It just says, hey, I'll just add 5 to my position. That's it. And when I go ahead and run this, as you see, there's my first dot, and there's a moving dot. Now it's going to go beyond the edge. It should come out the other side, and that's why we added data. Because we'll say if my x went beyond the edge, then we'll set my x to 0. And now, there's my dot, there's a moving dot, and there it comes. Now, dot, moving dot, dot, moving dot. Now, want to see something cool? When I click in the dots, sure enough, the counter goes up. When I click in the moving dots, that happens as well, because a moving dot is a dot. And all the behaviors I get from dots, which means drawing, it means checking if I've clicked inside of it, I get from moving dots for free by way of inheritance. That's a beautiful use of inheritance. Excellent. So that's moving dot. Now we want to create a flashing moving dot. And a flashing moving dot is a kind of moving dot. So now down here, there's probably a cleverer way to do this, but for the sake of this example, we'll go ahead and do this. We'll do mod 3 now, and we'll create a dot, or a moving dot, or a flashing moving dot. So of course this will work. Oh, this should have been else, pardon me. And so when I run this, I get a dot, I get a moving dot. That's a flashing moving dot. Of course it doesn't flash yet. We've made it the same as a moving dot. So now to flash. How are we going to flash? There's a few things we have to do to flash. We have to change how we draw. We have to know if we're flashing. And then we have to change the fact that we're flashing every so often. So let's start by simply being in flash mode all the time. So we'll say self.isFlashing will be true. That feels like an instance attribute, which it is. So you want to set it inside a init. Self.isFlashing is true. Great. Now a couple things. When we initialize a dot, what do we provide? Well, we provide x and y. So when we create a flashing moving dot, it's still a dot, so we're going to send in x and y. And like we discussed above in the notes, you want to make sure that you call the init method of my superclass. What's interesting, by the way, is moving dot doesn't have an init method. So when you do this, it'll inherit straight through moving dot, and it'll inherit from dot and run this init method, which is very important because otherwise you're not going to set x and y and store those. You're not going to create your random radius. You're not going to create your fill color. You're not going to create your click count. So it's really important that we call our init. Now we know that we are flashing. Next thing we're going to call is we're going to create our own draw method. Okay, and our draw method is going to be similar to the draw method of dot. What we're going to say is if I am flashing, then I'll go ahead and I'll draw the flashing. It's a rectangle, and it goes around instead of the fill. We'll say the flash fill is always say green. Actually, is green one of the colors we have here? It is. How about let's say blue's not. We'll just do blue. All right. So now this is buggy, but let's see it work. We'll go ahead and run this, and there's our dot, a moving dot. Here's a flashing dot. It's a solid blue rectangle that never changes. Now, we know it never changes because we said self-is-flashing is true, and we never set self-is-flashing to false. And so it's not going to flash. But why aren't we getting a circle inside of there? And the answer is, inside our draw, we overrode the superclass's draw. We're never calling it. So the only thing it's going to do is this. We meant to do this and to call the superclass's draw on the canvas. And that fixes things, as you can see here. Of course, I know it doesn't, and it still doesn't. Ugh. Why? Because we're drawing the superclass's circle first and then immediately putting a blue rectangle over it. We meant to put the blue rectangle first in the background and then draw. And now you can see there's our dot, there's a moving dot. Here we go, flashing dot. And indeed, we have the blue behind the circle, dot, moving dot, flashing dot. Awesome. So now we want to make the flashing dot actually flash. For that, we want to set is flashing to false and true alternating every so often. So to do that, we'll have a flash count, self.flash count, which initially is 0. And now we have to have in our step, we have to say self.flash count plus equals 1 if self.flash count is equal to, that's just a magic number that you should probably not, we should put it in a well-named variable, but then self.isFlashing is not self.isFlashing, and self.flash count equals 0. So now every time we get to 5, we'll say if we were flashing, stop, and if we weren't, start. And we run, this has a bug, but it's close. There's a dot, there's a moving dot, there's a flashing dot. It is now flashing, but somehow it stopped moving. The reason for that is the moving and moving dot occurred in step. When we created this step, we overrode this step and never called it. Aha! So we meant for a flashing moving dot, you still have to do the moving dot step, but then in addition do the things that require for flashing. Which now here's a dot, here's a moving dot, and flashing moving dot. Aha! Dot, moving dot, flashing moving dot. And if I click inside a flashing moving dot, the counter goes up. The only thing left to do now is to record the number of dots. Technically, we can get that out of data dots, just the length of that. But we're going to do it a different way to showcase class attributes. I'm going to create the class attribute of dot count. Initially, I have no doubts that I have no dots. Now, every single time I create a dot, whether it's a dot or a moving dot or a flashing moving dot, every single time it'll eventually call dots init. So right inside dots init, I will say that my dot count plus equals 1. Add 1 to dots dot count. Mind you, this is shared, one value shared across all instances. That's what we want. So there's only one dot count, not one per instance. We increase that one dot count. Now, when we're drawing at the top level right here, we'll go ahead and do a canvas, create text, data width over 2, height of say 20, and the text can be %d dots, and that is dot count. And let's put this where you can see it. And now let's see if this works. I've created 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots, 7 dots, and we are